Hey physics, it's time to talk about power. What's power? Power is, well, certainly that word gets kicked around in the non-physics world, but in physics, power is defined to be the rate at which energy is moved around. And if you think about, like, how does energy get moved around? Well, it gets moved around by work. So you could also say it's the rate that work gets done at. And that's it. So note's over. Just kidding. I got to tell you a little bit more. First of all, the units for this: energy, work measured in joules, time measured in seconds. But power is one of these units that gets its own name. So a joules per second is what we call watts. And you've heard this, underlining these because those are the letters we use to abbreviate those. You've heard watts before with like light bulbs and appliances and electricity kind of stuff. And we'll come back to that idea in just a minute. So that's really all that you need to know. So let me give you an example. Let's say you have an elevator. Needs to lift let's see, an elevator cab plus the people in it. Let's say that's 1,000 kilograms. That's probably fairly reasonable. 1,000 kilogram, a motor. The elevator motor is going to be attached to the cable, right? It's going to pull the elevator up. It needs to lift a 1,000 kilogram elevator. Let's see. How about a 50-meter elevator shaft, and that's going to happen in, let's say, 50 meters, maybe 15 seconds. How much power is required? Well, you can, I think you could do this probably without an LOL diagram, but I'm going to make one because we're in the habit of doing that. So here's the elevator at the bottom, here's the elevator at the top. At the bottom, we'll say that's like its zero height, so it doesn't have any EG yet, and when it gets up here, it does have some EG, and it's the work done by the elevator, or the work done by the motor, that's putting that energy in there. And this would be the elevator and the earth, right? And the motor would be outside the system. It's doing work like that. So the work done by the motor is just equal to this gravitational potential energy, which is 10 times the mass of the elevator times the height, 50 meters. So that's, 5 followed by 1, 2, 3, 4, 5 zeros. 500,000 joules. And so the power is equal to the work done by the elevator, or the motor rather, divided by time. So that's 500,000 joules. And going to do that in 15 seconds. So 500,000 divided by 15. So you would need about a 33,000 watt motor to do that. that's all you need to do. There is one more other thing that I should tell you here about power. Also, power is, if power is equal to work divided by time, and you remember work is equal to a force times a distance if the force is constant. And so if I made that substitution, it would be force times distance over time. But if we're going at a constant velocity, then distance divided by time is just that velocity. So you can also find power by doing force times velocity. And I'll give that all to you. All those equations will show up on your test. Sorry if you couldn't see that at the bottom of the screen. There it is. That's what I was writing there. Now the other interesting thing, because you've seen power ratings on appliances and like 60-watt light bulbs and things like this, I want to just talk to you a little bit about what you're paying, like what that means, and what you're paying for when you pay your electric bill and all that. So the electric company, whichever one, Bark or Dominion around here, the electric company, they charge you all sorts of fees, but the actual, like the thing that you're buying from them that might be more or less depending on how many light bulbs you leave on and all that kind of thing, the electric company charges you for what they call kilowatt hours. Not kilowatts per hour, it's kilowatt hours. That's what they're selling you. And kilowatt hour is usually about somewhere like 5-10 cents, something like that for a kilowatt hour. So what is a kilowatt hour? Well, a kilowatt, 1 kilowatt times hour. A kilowatt is, kilo means 1,000, so that's 1,000 watts, times an hour is 3,600 seconds. That's converting it to SI units. And a watt is a joule per second. So joules per second times seconds, the seconds cancel out. 1 kilowatt hour is 3,600,000 joules. So 3,600,000 joules from the electric company costs you about 10 cents. How about that? So what does it mean for a 60-watt light bulb? Well, watts is joules per second. So 60-watt light bulb, when it's on, uses 60 joules every second. So what if you left a 60-watt light bulb on for, let's say you leave it on, there's a light in your closet or something, and you turn it on because you're getting something out of your closet, and then you shut the door and you forget to turn the light off. And let's say you leave it on for a whole week. Let's see how much energy that is going to use. So 1 60-watt light bulb left on for 1 week. Okay, so let's see. First of all, we need to figure out how many seconds that is. So we just need to do 60 watts times 1 week. Well, we need to convert that. So 60 watts is 60 joules per second times 1 week is 7 days times 24 hours times 3,600 seconds in an hour. You could do times 60 if you want. That's how many seconds there are in a week. 7 times 24 times 60 times 60. So let's see. The seconds are going to cancel out, and we're going to get some number of joules here. Whatever 60 times 7 times 24 times 3,600. So let's see, that's about 36 million, if I'm moving my decimal right there. Yep. So 3.6 times 10 to the 7th joules. All right. So what if 1 kilowatt hour costs 10 cents? So then, there's two ways you can do this. If you know that a kilowatt hour is 3.6 million joules, then you can just divide this by that. So that's going to be 10 kilowatt hours. This is 3.6 times 10 to the 6. So if we have that many joules, this is how many joules in 1 kilowatt hour, so that's going to be equal to 10 kilowatt hours. And the electric company is charging you a dime per each, so 10 kilowatt hours times that cost $1. That's one way to do it. The other way to do it would be to change this right here, 60 watts times 1 week, to change this into kilowatt hours, kilowatts times hours. So if we do that, 60 watts is the same as 0.06 kilowatts, right? Moving the decimal 1, 2, 3 places to turn it into kilowatts. And then 1 week is how many hours? Well, a week is 7 days, and there's 24 hours in a day. So 7 times 24, that's how many hours there are in a week, times 168 hours. And that's kilowatt hours. So 0.06 times 168, is about 10. And then you get the same thing, so I end up at the same place. And each kilowatt hour costs 10 cents, so that's going to cost you $1 for leaving that light on for a week. All right, I'm going to do some problems for you in the next video.